Okay, we're going to focus on binomial expansion, and we're going to look for unknown exponents with it. So this is our binomial that we're going to expand, okay? And we're going to write some questions after, but the first thing I'm going to do is we're actually going to work through our Pascal's triangle, okay, and relate it to binomial expansion. So if you're familiar with it, it starts with the number 1, right? And then in the second row we have 1 and 1. Okay. Now in the second row, this row here, this is where you have a binomial. Okay, because there are 2 terms. Okay, and bi is in 2, so 2 terms is where binomial expansion really starts. So this is where you get, we'll write our a plus b to the power of 1. Right? These are essentially your coefficients. This here represents a plus b to the power of 0. Anything to the power of 0 is the number 1. Okay. And then our third row, or for binomial expansion, it's to the power of 2. We end up with 2, or 1, 2, 1. Okay. Then we end up with 1, 3, 3, 1. Then we end up with 1, 4, 6, 4, 1. Okay. And again, this is, I'm just going to write it like this. This is power of 2, power of 3. This is how you write a power on a computer. Power of 4. And then because we're at the power of 5, we go 1, 5, 10, 10, 5, 1. Are you okay with how I built that?
Yeah.
Yeah, I essentially just add those, right? So we add these 2. Oh, sorry, what am I talking about? Add these 2, we get our 2. Add these 2, 3. Add these 2, these 2, these 2. That's how we get our numbers. Okay, so these are going to be our coefficients as we go through it, okay, when we go to build it. So if I was to actually expand this, okay, we have our a plus b to the power of 5. Okay, I just want to have it all on one side. Okay, we know that our first term is we're going to take the first term and put it to the power of 5. Okay, so we're going to have our coefficient 1. Okay, so this will be equal to 1. And then we have a to the power of 5. And technically we have b to the power of 0. Okay, our exponents always have to add up to what our power is here. Okay. So we have our 1a5b0. Then we have our, and we would technically add, our next coefficient is 5. Do you know what our powers are? A4, B1. Essentially our A we're just going to count downwards, and our B we're going to count upwards with our exponent. Okay, so let's kind of continue this pattern. What would be my next coefficient?
10.
Yeah, 10's our next coefficient. What would my A be? To the power of
3.
Yeah, and what would the B be to?
B2.
Yeah, great. All right, what's our next coefficient?
10 again.
10 again. And we have
A2.
Yeah.
B3.
Yeah. That's our next coefficient.
5.
Yeah. So plus 5. What are our A values?
A2.
We've already done A2.
A1.
Yep.
And then B4.
Yep. And then finally, our last coefficient?
1.
1. And A?
Just A.
Well, technically it's to the power of
0.
0, and B to the power of
5.
Okay. Now this can all be technically simplified, and it's just these two. B to the power of 0 is just the value of 1, so you usually write this as a to the power of 5, because times 1 doesn't do anything. Same with this here. A to the power of 0 is technically the value of 1. 1 times anything is the same. And 1 times b5 is b5, so you usually just write that as b to the power of 5. Everything else is correct, okay? So, assuming we didn't know this idea, let's say they gave us a question like this. Oh, we have 10 A, and we'll say k's are unknown, and b to the power of 3. Okay, we have to figure out what our k value is from this. Okay, so kind of without trying to look at this, even though it's very much on our screen, remember our exponents have to add up to what value?
3.
Well, actually, they have to add up to whatever our power is on our binomial. So in this case, the easiest way to figure out what k is, and let's make a small equation. We'll do it in blue here. K and 3, they have to add up to our 5. So we know that 5 is equal to k plus 3. Let's isolate for k. We bring 3 over. You get 5 minus 3 equals k. K is equal to the value of 2. And that works out, right? We have a 10 A2 B3, yeah, that's right there in our binomial. What if we had this idea? 5A4BK. What do you think our K would be in this case? 1, that's right. And even though there are two coefficients of 5, we just focus on our exponents, and we know that 4 plus 1 will equal 5, and then, lo and behold, we're talking about that value within it. Now, I didn't give us the next set, so let's assume I want to show us one more type. I'll show you one more type. Let's say this is a b to the power of 6, okay? And I'm going to make up the value. It is going to be 20a k b k. Okay. So, a little tougher. Our k's, they haven't given us either. But we know they have to add up to what value? 6, okay? The good thing about this is they're the same variable. So let's build our question again in blue. K plus k equals 6. Can you well, that's not 6, that's 2. Can you simplify our k here?
K squared.
That would be if it's multiplying. If it's adding, you add the two coefficients. So imagine there's a 1 and a 1.
So 2k.
Yeah, 2k equals 6. How do we isolate for k?
Divide 6 by 2.
Yeah, so we divide both sides by 2, or you bring the 2 over, whichever you want to refer to. And k is equal to what?
4.
3 in this case, yeah. So, let's see if this makes sense. 20a3, b3? Does 3 plus 3 equal 6?
Yeah.
Yeah, so that checks out. There we go. It works out great. Okay, so you can essentially figure out anything that way by knowing to add your exponents. And in this one, because they're the same, we knew the number had to be the same. Okay.